This is my intermediate algebra course. Today we're going to continue to learn transformations and the library of relations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the previous classes, we reviewed transformations at the left, and we introduced the idea of a relation at the right. You can look over that information if you'd like here. We also introduced the library of relations. Be sure to get a picture of the library with your phone. You're going to need that in front of you as we go along today, as in the previous classes. You're also going to need the transformation properties at the right. Please get a picture of this library with your phone. If you want to look on the internet, it's going to be called the library of functions. Again, you're going to need those right in front of you as we work along today in the class. Here's the rest of the transformation properties at the left. In the previous class, we graphed complicated equations using the transformation method. And I mentioned that the biggest problem that students have is they think they use the transformation properties correctly, but actually they don't apply the properties correctly. So in the previous class, I designed the problems so that it was impossible to really make those types of mistakes. I gave you the order that we transformed the graph. But today you're going to learn how to figure out how to build an equation and transform the graph yourself without making any mistakes. But before we go into that, let's talk about the type of mistakes that students make. So we're going to graph this complicated equation here, and as usual we're going to start with the parent graph here, and we're going to write a negative on the x, which reflects across the y-axis because there's a negative up here in our equation next to the x. Then we're going to replace x with 2x, obviously because there's a 2x up here in our complicated equation. Then we're going to replace y, and by the way, that divides all the x values by 2. So you're going to take all the x values on this red graph here, divide them by 2, and you get this graph. Everything so far is correct. Then we're going to replace y with y plus 3. That's going to move this graph down 3 units. So we did that. That's correct. Everything we've done is correct so far. But here's where we have the problem. You see, we have a 4 up here added to the negative 2x. So we're then going to add 4 to negative 2x. We have negative 2x in the previous equation. We're going to add 4 to that. And it looks like we're adding 4 to x, but actually we're not. We're adding 4 to negative 2x. A lot of students would say, well, I'm adding 4 to x here, so I can just move the graph of the previous equation 4 units to the left. But again, we're not adding 4 to x, we're adding 4 to negative 2x. It's not the same thing. Now, it's very important to understand that we have the correct equation. There's nothing wrong with the equation. Do you see that? It's the same equation that we have up here. There's nothing wrong with the equation. It's just that we can't move the graph of the previous equation to the left 4 units because we didn't add 4 to x. We added 4 to negative 2x. These are the kinds of problems that students have when they try to use the transformation method to graph complicated equations. Now, I know what you're thinking. You're thinking, well, what does that do to the graph? If you add 4, I mean, you've got the correct equation, right? If you add 4 to negative 2x, it does something, right? And the answer is yes, it does, but we can't see what it's doing. The transformation properties don't tell us what to do in that situation. So what we can do is we can take negative 2x plus 4. Well, let's start with root negative 2x. So we have root negative 2x here, right? Then we add 4 to negative 2x, but we can't see what's really going on with the graph. So what I'm going to do is I'm going to take this equation here, I'll make it blue, and I'm just going to change the form of that blue equation. I'm going to factor out a negative 2. Now don't be confused by that. If you multiply the negative 2 back into the x, you get negative 2x. And if you multiply the negative 2 into the negative 2 using the distribution property, then you get positive 4. Okay, so use distribution to go backwards, and you can see we get right back to this expression. So all I did was I changed the form of this expression to this expression here. So we had root negative 2x in the previous equation. Then we added 4 to that, which is the same thing as changing this pink equation to that bottom equation there. So we're changing this pink equation to this bottom equation here. So what did we really do? What we did was we actually, look at this purple highlight here, what we did is we actually moved the graph 2 units to the right. By adding 4 to negative 2x, we didn't move the graph of the previous equation 4 units to the left. We actually moved it 2 units to the right. So there's nothing wrong with adding 4 to negative 2x, but you have to change the form of that expression in order to use the transformation properties to see what's happening. The transformation properties don't tell us how to change a graph when we add 4 to negative 2x. But they do tell us how to change a graph when we replace x with x minus 2. When you subtract 2 from x, then you move 2 units to the right. So are we allowed to add 4 to negative 2x in this class? Actually, we're not going to do that in this class. We're not going to do those types of things because we want to avoid having to change the expression. We want to just use the transformation properties directly without having to change the form of the expressions. So if we move this graph 3 units down, that's okay, but if we move it 4 units to the left, as you can see down here, that's the wrong graph. What we need to do is we need to take this graph and move it 3 units down and then 2 units to the right. That would actually give us the correct graph. So that graph would look like so. That's the correct graph. See how it's moved 2 units to the right. So we need to get into some practice problems here. So if you'd like, you can look over some of these. For each problem, we're going to study 6 different pathways to build the equation and use transformation properties to build the graph. So here's one example. 4 of those possible pathways are wrong and 2 are correct in that example. Here's another example using the absolute value relation. These 4 pathways are incorrect. And we have 2 pathways at the left that are correct. You see, here's another example. We're going to graph this complicated equation. And we start with the parent graph. Then we replace y with y minus 4 and x with x minus 1. So everything's fine so far. We're going to move the graph up 4 units and to the right 1 unit. But then we're going to divide x minus 1 by 2. Well, that's where the problem is. You see, the transformation properties tell us that if we divide x by 2, then we multiply all the x values of the graph of the previous equation by 2. The problem is we're not dividing x by 2. We're dividing x minus 1 by 2. You see, so there's another example where we think that we're following the transformation properties directly, but not really. Now we can still graph it using the transformation properties, but again, we'd have to modify the expression. So you can look over these examples. With each problem, each example, there's going to be one or two variations where the transformation properties are used properly, and the other 4 or 5 are going to be examples where they're not used properly. Okay, so let's get into some practice problems, because remember, when it comes to math, you're not really learning anything unless you're doing practice problems. So what we're going to do is we're going to graph this complicated equation, and I've given you 6 different pathways that you can choose from to build the equation and use the transformation properties to build your graph of this equation, starting from the parent graph. And I want you to understand very clearly that all of these pathways lead to the correct equation. And we can use the transformation properties in every one of these cases to build the correct graph with the transformation property. But there's only a few of these pathways that you can use without having to modify expressions in the equation. We don't want to modify. We want to use the transformation properties directly, the way that they're written, without having to do any math. So let's try this first problem here, and when we choose a pathway, we're going to then use the transformation properties to graph the equation. So let's see if pathway number 1 is going to work. And the whole purpose of this is to help you to avoid using the transformation method incorrectly. So we're going to start with our parent equation. So we've got our parent equation. It's the correct equation because we have a square root here. Then we're going to replace y with y minus 1, obviously because we have y minus 1 in our equation up here. And we're going to replace x with x plus 3 because we have x plus 3 in our equation. And I'm going to put a green check next to that because the transformation properties tell us that if you replace y with y minus 1, you move the graph up 1 unit. And if you replace x with x plus 3, you move the graph 3 units to the left. So far, this pathway is working. We don't have any potential problems using the transformation properties directly. But the second step is a step where we're going to have an issue. We're then multiplying y minus 1 by 2, because obviously we have a 2 multiplied into y minus 1. There's nothing wrong with that. We're building the correct equation, but the problem is the transformation properties don't tell us what to do in that situation. You see, if we put a 2 just on the y, if we multiplied only y by 2 and not the entire difference, y minus 1, then the transformation properties would tell us to divide all the y values of the graph of the previous equation by 2. But that's not what we're doing. We're multiplying the entire difference, y minus 1 by 2. The transformation properties don't tell us what to do in that situation. So if we were going to build the equation with this pathway and use the transformation properties, what we would have to do is we'd have to change the form of this. We'd have to change it to 2y minus 2. Then we can see that we are actually translating the graph because we had y minus 1. Then it somehow changed to 2y minus 2. So we don't have a minus 1 anymore. So we're actually moving the graph up 1 unit. And then we're dividing all the y values by 2. So there's a lot going on. There's 2 different transformations occurring at the same time. And we had to change the expression. We had to change the expression to this form out here, 2y minus 2. So we want to avoid doing all that. So we're not going to use this pathway. The same is true when we changed x plus 3 to negative x plus 3. We didn't just write a negative on the x. If we write a negative on the x, then that tells us to reflect across the y-axis. But we wrote a negative on x plus 3. Now, again, can we change the form of that? Can we change negative x plus 3 to negative x minus 3 and then understand what's happening? Yes, we can. But the problem is we have to change the form, and we also have to perform two different transformations. So it's kind of complicated. So we want to avoid that. Now, again, I want to make it clear there's nothing wrong with this pathway. We can use that pathway. It's just it makes things a little more complicated. We want to use the transformation properties the way that they're written in the simplest way possible. So let's try pathway number 2. We're not going to use pathway number 1. So we have our parent equation. We replaced y with y minus 1 and x with x plus 3. That just tells us to move the graph up in 3 units to the left. And then we replace x plus 3 with negative x plus 3. That's where we have the situation. The transformation properties tell us what to do when you write a negative on the x and the x only. But we didn't write a negative only on the x. We wrote a negative on the x plus 3. Then we multiplied y minus 1 by 2. And for the same reason, pathway number 1 didn't work, pathway 2 didn't work. At least it doesn't work without a lot of complications. So let's try pathway number 3. We have our parent equation, that's correct. Then we're going to multiply y. Now, in this case, we're only multiplying y. So the transformation properties tell us take all the y values of the graph of this equation and divide by 2. So that's okay, that's simple. So we know what to do there. Then we're going to replace x with negative x. So that's fine. That just tells us to reflect across the y-axis. So far, we can use the transformation properties directly. We don't have to modify any expressions. We're not doing two types of transformations in one step. Everything is simple. Then we're going to replace x with x plus 3 and y with y minus 1. And that just tells us to move the graph of this equation to the left 3 units and up 1 unit. So there you go. That pathway works. Now again, technically all the pathways work. It's just that this is the pathway that is simplest. We can use the transformation properties without doing a lot of extra math and thinking. So this may seem kind of tedious. I mean, when you learn how to use the transformation properties properly, you're not going to have to do all this stuff. It's very important to understand you don't have to draw out, all these pathways. You're going to understand how to do these problems very quickly in your head. And it's going to take literally, seconds, 20, 30 seconds to graph a complicated equation like that. But now we have to be very careful to avoid the possible mistakes. So let's go on to pathway number 4. Again, the equation that we have down here is the correct equation. But let's see if this pathway is going to be simple, or are we going to have to modify expressions. So we're starting with the parent equation. That's correct. We replaced y with 2y. That tells us to divide all the y values of this graph by 2. Then we're going to replace y with y minus 1 and x with x plus 3. That tells us to move the graph up 1 unit and to the left 3 units. Everything's fine so far. But then we have a problem. We're changing x plus 3 to negative x plus 3. The transformation properties tell us to write a negative on the, if we write a negative on the x, then we reflect across the y-axis. But we didn't just write a negative on the x, we wrote a negative on x plus 3. So the transformation properties don't tell us what to do in that situation. If we modify this expression, then we can figure it out. But we don't want to do that. Okay, So we're not going to use pathway number 4. Pathway number 5, we're going to start with the parent equation. We're going to replace x with negative x. That tells us to reflect across the y-axis. Then we're going to replace y with 2y. That tells us to divide all the y values of this equation by 2. And then we're going to replace y with y minus 1 and x with x plus 3. That tells us to move the graph up 1 unit and to the left 3 units, so that one works also. We can use the transformation properties without modifying expressions or doing 2 transformations in one step, so on and so forth. So let's check this last pathway. We have the right parent equation. We're going to replace x with negative x. Then we're going to replace y with y minus 1 and x with x plus 3. That tells us to move up and to the left. And then we have a problem. We're going to multiply y minus 1 by 2. The transformation properties tell us how to modify the graph if we're multiplying y by 2, but it doesn't tell us what to do if we're multiplying y minus 1 by 2. So it's not that we're not building the correct equation. We have the correct equation. It's just we can't use the transformation properties without modifying expressions in the pathway. So now we need to choose one of those pathways that worked. We can choose pathway number 3, or we can choose pathway number 5. And pathway number 5 is a little easier to get to here, so we're going to use pathway number 5. And I'm going to unveil that pathway. That pathway is reflection first, then dilation, then translation. So now that we know the pathway to use, we're going to graph just like we did in the previous class. So I'm going to do this kind of quickly because you've already seen this. So we have the reference point 0, 0, 1, 1, and 4, 2. And then we're going to reflect across the y-axis. So that's just going to flip over the y-axis. And then we're going to, looks like I forgot to write the dilation. Let me put the 2 there. So then we're replacing a y with 2y. So that means we're going to divide all the y values of the points of this graph by 2. So the y value of this point is 2. Divide by 2, you get 1. And the y value of this point is 1. Divide by 2, you get 1/2. And there you go. So we can connect the dots. So that was a vertical compression. We pushed down. And then we're going to translate. We're going to move that graph 1 unit up and 3 units to the left. So 1 unit up, 3 units to the left. And we can connect the dots, and there you go. So that's roughly what the graph looks like. So that is the graph of the equation. We chose the appropriate pathway to transform the graph so that we can make things simple without having to modify expressions, and we graphed the complicated equation. All right, let's try another one of these. We're going to graph this complicated equation. So let's start with the parent equation. We have the right parent equation there. Then we're going to replace y with y plus 4 and x with x minus 2. That tells us to move to the right 2 and down 4. And then we're going to replace x with x over 2. That tells us to multiply all the x values of the graph of the previous equation by 2. So that's fine. And then we're going to replace x with negative x. That tells us to reflect across the y-axis. So that pathway makes it very easy for us to use the transformation properties. So that pathway works. Let's see if any other pathways work. So we're going to start with the parent equation again. Replace y with y plus 4 and x with x minus 2. Then we're going to write a negative on the x that tells us to reflect across the y-axis. Then we're going to replace x with x over 2. So that works also. That just tells us to multiply all the x values of the graph of the previous equation by 2. So we have two pathways already that we can use. Let's see if there's any more. We're going to start with the parent equation. Replace x with x over 2. That tells us to multiply all the x values of the previous graph by 2. Then we're going to replace x with negative x. That's fine. But here's where we have the problem. We're replacing y with y plus 4. That's okay. That tells us to move the graph down 4 units. But here, we're not subtracting 2 from x. The transformation properties tell us that when you subtract 2 from x, you move the graph 2 units to the right. But we're not subtracting 2 from x. We're subtracting 2 from negative x over 2. The transformation properties don't tell us what to do in that situation. Now again, we can modify the expression so that we can figure out how to transform the graph, but we don't want to do that. We want to make things as simple as possible. So we're not going to use pathway number 3. Okay, on to pathway number 4. Again, all of these equations down here are correct. There's nothing wrong with the equations. It's just that we can't use the transformation properties in every pathway without modifying expressions. So we have the parent equation. We're going to replace x with x over 2, multiply all the x values by 2. But then we have a problem. We're going to subtract 2 from x over 2. The transformation properties don't tell us what to do in that situation. After that, we replace x with negative x. That's okay, but the third step there, or second step, whatever you want to, however you want to number the steps, that's not going to work. Okay, so pathway number 5, we're writing the parent equation, replacing x with negative x. That tells us to reflect across the y-axis. Then we're going to replace x with x over 2. That tells us to multiply all the x values by 2 in the graph of the previous equation. And then we're going to subtract 2 from negative x over 2. That's the problem. The transformation properties don't tell us what to do in that situation. Now again, we could modify the expression so that we could figure out what exactly it is telling us to do, but that'd be kind of complicated. So we're not going to use pathway number 5. Let's try pathway number 6. We're going to write the parent equation, replace x with negative x. That tells us to reflect across the y-axis. Then we're going to subtract 2 from negative x. You see this? We're subtracting 2, not from x. We're not subtracting 2 from x. We're subtracting 2 from negative x. The transformation properties don't tell us what to do in that situation. Then we're replacing x with x over 2. That tells us to multiply all the x values by 2. That's okay, but pathway 6 is going to be a little complicated. So we're going to use either pathway 1 or pathway 2. So let's use pathway number 1. I'm going to unveil that pathway. It's translation, dilation, and then reflection. So now that we know what pathway to use, let's go ahead and graph. Remember, the x cubed graph, the cubic graph, is a little difficult to draw. So I'm leaving this one for myself so you don't have to do it. Whoops, looks like we accidentally erased something there. There you go. So now we're going to translate. We're going to move 2 units to the right and 4 units down. And we're going to connect the dots. Okay, then we're going to dilate. You see we're replacing x with x over 2. So that means we're going to multiply all the x values by 2. So the x value of this point is 2. So that's going to become 4. and the x value of this point. So that point went to there, and this point is going to go here, and the x value of this point is 3. So we multiply that by 2, we get 6. And so then we can connect the dots. Okay, then we're going to reflect. We're going to replace x with negative x. So that tells us to reflect across the y-axis. So this point is 1, 2, 3, 4 units from the y-axis. Then we're going to go 4 units in the other direction. And same thing with all the other points. And there you go. So that is the graph of the final equation. We chose a simple pathway, pathway number 1, and we use the transformation method. So let's try a couple more of these before you try one on your own. Now we're going to go to the logarithmic relation. This is a pretty complicated graph here. Complicated equation, I mean. And let's try some different pathways. So we have a logarithmic expression, obviously, so we're going to use a logarithm. We have our parent equation. It's base 2 because our logarithm up here is base 2. Then we're going to replace y with y minus 3 and x with x plus 1. That tells us to move the graph 3 units up and 1 unit to the left. Then we're going to divide x plus 1 by 3. Well, that's a problem. The transformation properties tell us what to do if we divide x by 3 and x only by 3. You see, if we took that and divided x by 3, not the 1, just the x, then the transformation properties would tell us what to do. Okay, but we're not doing that. We're dividing x plus 1 by 3. So we'd have to modify that expression in order to see what's going on. Then we replace y with negative y. That just tells us to reflect across the x-axis, but because the third equation there gives us some complications, we're not going to use that pathway. So now let's go to pathway 2. We have the parent equation, and we're replacing y with y minus 3 and x with x plus 1. That tells us to move up 3 and to the right, or to the left, that is, 1. Then we're replacing y with negative y. That tells us to reflect across the x-axis. So that's pretty simple. But again, we have a problem. We're replacing x plus 1 with x plus 1 over 3. So the transformation properties don't tell us what to do in that case. If we were only dividing x by 3, then the transformation properties tell us what to do, but we're dividing x plus 1 by 3. So that pathway is not going to be the appropriate choice. Now we're going to try pathway number 3. We start with the parent equation, replace x with x over 3. That tells us to multiply all the x values of the points in the previous graph by 3. Then we're going to replace y with negative y. That tells us to reflect across the x-axis. Then we're going to replace x with x plus 1. That tells us to move the graph 1 unit to the left. But over here we have a problem. The transformation properties tell us that when you subtract 3 from y, then you move the graph up 3 units. But the problem is we're not subtracting 3 from y. We're subtracting 3 from negative y. The transformation properties don't tell us what to do in that situation. We could figure it out. It's not that we can't figure it out. It's just it's going to make things a little more complicated. So we don't prefer that pathway. Okay, pathway number 4. We have the parent equation. We're replacing x with x over 3. And then we're going to replace y with y minus 3 and x with x plus 1. So in this situation, we multiply all the x values by 3. Then we move the whole graph up 3 units and to the left 1. And then we're replacing y with negative y. That tells us to reflect across the x-axis. So in each one of those steps, we could use the transformation properties without having to modify expressions. So it looks like we're going to use pathway number 4. Let's try pathway number 5, see if that works. We have the parent equation. We're going to replace y with negative y. That means reflect across the x-axis. Then we're going to replace x with x over 3. That means stretch horizontally. We're going to multiply all the x values by 3 in the graph of the previous equation. And then we're going to replace x with x plus 1. That tells us to move the graph 1 unit to the left. But here we have the same problem that we did before. We're subtracting 3 from negative y. The transformation properties don't tell us what to do in that situation. If we subtract 3 just from y, that means move up 3 units, but we're not doing that. We're subtracting 3 from negative y. So we'd have to modify that expression to see how the graph is being translated. All right, pathway number 6. We have our parent equation. We're going to replace y with negative y. That tells us to reflect across the x-axis. But then again, immediately we have a situation. We're subtracting 3 from negative y. So that's not going to be the best choice. And if that were not bad enough, then in the next step, we're dividing x plus 1 by 3. Again, the transformation properties don't tell us what to do in that situation. So now we have our pathway. We're going to use pathway number 4, obviously. In this case, there was only one pathway that was appropriate. So we have our route. We're going to dilate first, then translate, then reflect. Remember, there's a vertical asymptote on the y-axis when you're drawing the logarithmic parent relation. And if we plug in 1, you always get 0 in a logarithm, right? If we plug in a number that's the same as the base, 2, then we always get 1. And if we plug in powers of 2, like 4, then we can find the rest of the values. Plug in 4, we get 2. And the next power of 2 would be 8, but that goes off the window. So then we can connect the dots. And there you go. Okay, so now we're going to replace x with x over 3. That means we're going to multiply all the x values by 3. Now, the asymptote is on the y-axis, so it's not going to change positions. So the x value of this point here is 1. So the new x value is going to be 3. So that point went to there. The x value of this point is 2, so multiply by 3, we get 6. So that point went there. And then we can connect the dots. And don't worry about points in this region here. We don't have to get that detailed. Okay, so that was a horizontal stretch. The graph's a little clunky there, but that's okay. All right, now we're going to translate. We're going to move 3 units up and 1 unit to the left. So because we're moving 1 unit to the left, the asymptote is going to change positions. And we're just going to move each point 1 unit to the left and 3 units up. So this point went to there. And to get to the next point, we go up 1 and 1, 2, 3. So over here we're going to go up 1 and 1, 2, 3. And there you go. So again, the graph doesn't have to be perfect. We could be more accurate in this area, but that's not really the point of this class. Okay, now we're going to reflect. We're reflecting across the x-axis because we're replacing y with negative y. So when you reflect across the x-axis, it doesn't really change the position of the asymptote because it's a vertical asymptote. But this point here, we have to figure out how far from the x-axis. It's 3 units. So we're going to go 3 units on the other side. And same with the other point. And there you go. So that is the graph of that equation. So we're doing the same thing we did in the previous class. The difference is we're learning how to choose the proper pathway. Do you dilate first? Do you translate first? Do you reflect first? So on and so forth. Okay, so let's try one more of these before you try one on your own. Now we're going to the reciprocal relation because there is an x in the denominator of the fraction. So we're going to start with our parent equation. Then we're going to replace y with y plus 2 and x with x plus 3. That tells us to move the graph down 2 units and to the left 3 units. Then we're going to replace x with 2x. That tells us to divide all the x values of the graph of this equation by 2 to get the graph of the next equation. So that's fine. And then we're going to replace x with negative x. And the purpose of this pink writing here is to tell you that if you replace x with negative x, then you can just multiply these. 2 times negative x is just negative 2x. You can use the commutative property of multiplication. So even though this equation doesn't look exactly the same as this equation, they're the same. And so if you replace x with negative x, you just reflect the graph across the y-axis. So that means that pathway number 1 works. Okay, let's try pathway number 2. We have the parent equation, replacing y with y plus 2 and x with x plus 3. Move the graph 2 units down and 3 units to the left. Then we're replacing x with negative x. That just tells us to reflect across the y-axis. And then we're replacing x with 2x. That tells us to divide all x values by 2. So both of these pathways work. Let's try pathway 3. We're going to write the parent equation. Then we're going to replace x with 2x. Then we're going to replace x with negative x. In each one of those situations, the transformation properties tell us how to modify the graphs or to transform the graphs. So remember, 2 times negative x is just negative 2x. So in the next step, we have a problem. We're replacing y with y plus 2. That's okay, but we're adding 3 to negative 2x. We're not adding 3 to x. If we were adding 3 to x, we just move the graph of the previous equation to the left 3 units. But we're not just adding 3 to x. We're adding 3 to negative 2x. The transformation properties don't tell us what to do in that situation. We could figure out what to do, but we'd have to modify the expression and do more thinking. So we're going to avoid that pathway. Okay, pathway number 4. We have the parent equation. We're going to replace x with 2x. That tells us to divide all the x values in the graph of the previous equation by 2. So that's fine. Then we're going to replace y with y plus 2. That tells us to move the graph down 2 units. But here's the problem. We're adding 3 to 2x. We're not adding 3 to x, we're adding 3 to 2x. So the transformation properties don't tell us how to modify the graph in that situation. Then we're replacing x with negative x. So that tells us to reflect across the y-axis, so that works. But we're not going to use pathway number 4 because of this complication here. In pathway number 5, we have the parent equation. Then we're replacing x with negative x. That tells us to reflect across the y-axis. Then we're replacing x with 2x. That tells us to divide all x values by 2. And then in the last step, that's where we have the problem. We're not adding 3 to x, we're adding 3 to negative 2x. The transformation properties don't tell us how to modify the graph in that situation. So we're not going to use pathway number 5. Pathway number 6, we have the parent equation. We're replacing x with negative x. That means reflect across the y-axis. But then we have an issue already. We're not just adding 3 to x. If we were adding 3 to x only, then we'd move 3 units to the left. But we're adding 3 to negative x. The transformation properties don't tell us what to do in that situation. Then we're replacing x with 2x. That's okay. The transformation properties tell us what to do, but we're not going to use pathway number 6. So we have pathway number 1 and pathway number 2 that we can use. So I'm going to unveil the pathway that we're going to use. We'll use pathway number 1. So let's draw our parent graph. Remember, the reciprocal relation has 2 asymptotes, a vertical and horizontal, and they're both on the axes. So we have our vertical and our horizontal. And remember, we have our 6 reference points. And connect the dots, understanding that we're approaching the y-axis as we go up and down, and we're approaching the x-axis as we go to the left and to the right. Now we're going to translate. We're going to move to the left 3 units and down 2 units. So now the asymptotes connect at that point. And then we need our 6 reference points, 1, 1, 1/2, 2, 2, 1/2, -1, -1, -2, -1/2, and -1/2, -2. And we're pretending that this is the origin here. That's why we can graph those reference points. We're pretending that that's the origin. Okay, then we're going to dilate. We're going to replace x with 2x. That tells us to divide all x values by 2. And so that's going to change the position of the vertical asymptote. Right now the vertical asymptote is at x equals 3, but we're going to divide by 2, so it's now going to be at 1.5. Sometimes you have to deal with fractions. I know it's not pretty, but sometimes you have to deal with those fractions. And we're going to divide all the x values by 2. So the x value of this point here is -4. So that's going to become negative 2. And let me draw the horizontal. The horizontal asymptote is not going to change positions. And this point here, the x value is -3.5. Divide by 2 and we get -1.75. Divide this x value by 2 and we get 2.5. Sometimes you do have to deal with fractions, like I said. Sometimes you just can't avoid it. So that's a little hard to graph, those points. but that's okay. Remember, this is not an art class. Your graph doesn't have to be completely perfect. You just have to get the main idea. Okay, so now we're going to reflect, and we're replacing x with negative x. We have a negative on the x by the commutative rule of multiplication. Remember, you can put the negative anywhere in a product. So now, because we're reflecting across the y-axis, remember when you write it negative on the x is the exact opposite of what you would think, reflecting across the y-axis. So our vertical asymptote is going to flip over to the other side of the y-axis. Our horizontal is not going to change positions. And all those points are just going to get reflected over. So this point here, the x value is negative 1. It's going to get reflected over to positive 1. And this x value is negative 1/2. It's going to reflect over to positive 1/2. And this point here, the x value is negative 1.25. So it's going to be positive 1.25, and then we can connect the dots, and you can see what's happening there. And the x value of this point is negative 2, so it's going to become positive 2. And the x value of this point is negative 1.75. It's going to become positive 1.75. Whoops, on the other side. And the x value of this point, I believe, is negative 2.5. It's going to become positive 2.5. And we can just connect the dots. So I know it's kind of hard to see these points, but remember, it's just, that happens sometimes. So that's the graph of that complicated equation. And we chose the correct pathway, pathway number 1, a pathway that would make it easier for us to use the transformation properties. So now it's time for you to try. Notice that I've blocked out the answers there because you're going to choose which pathway to use for number 5. So go ahead and attempt number 5. You don't need to have different colors. You can just use checks or crosses to show which steps can be used with the transformation properties. So go ahead and go through all these pathways and choose the best pathway that makes things simplest. And once you choose your pathway, then you can use the transformation method to graph the equation. And when you come back, we'll do it together. All right, we're back. Okay, we're going to start with the parent equation, and then we're going to replace y with y plus 1 and x with x minus 1. That tells us to move the graph to the right 1 and down 1. And then we're going to replace y with y over 3. That tells us to multiply all the y values by 3 in the graph of the previous equation. And then we're going to replace x with negative x, or we're going to replace x minus 1, that is, with negative x minus 1. So the transformation properties don't tell us what to do to modify the equation of this graph in that situation. If we write a negative on the x alone, that tells us to reflect across the y-axis, but we're not writing a negative just on the x. We're writing a negative on x minus 1. So the transformation properties don't tell us what to do in that situation. We could figure it out, but we want to use the easiest pathway. So let's try pathway number 2. We have the parent equation. We're replacing y with y plus 1 and x with x minus 1. That tells us to move the graph 1 unit to the right and 1 unit down. So the transformation properties tell us what to do there. But again, we have that same situation. We're writing a negative not just on the x, we're writing a negative on x minus 1. The transformation properties don't tell us what to do in that situation. And then we're replacing y with y over 3. That's okay, but one of those steps was not, it was a complicated situation. So let's go to pathway number 3. We have the parent equation. We're replacing y with y over 3. That tells us to multiply all the y values by 3 in the previous equation, or the previous graph of the equation. Then we're replacing x with x minus 1. That's okay. That tells us to move the graph to the right 1 unit. But here's the problem. We're adding 1 to y over 3. If we add 1 to just y alone, that tells us to move the graph down 1 unit. But we're not doing that. We're adding 1 to y over 3. The transformation properties don't tell us what to do in that situation. We're also writing a negative on x minus 1. Transformation properties don't tell us what to do in that situation either. Now again, we could figure it out, but it would be it introduces some complications. Okay, let's try pathway number 4. We have our parent equation. We're replacing y with y over 3. Then we're replacing x with negative x. So we multiply all the y values by 3, then we reflect across the x-axis. And then we have a problem. This is not the problem over here. We're replacing x with x minus 1. That's completely fine. The problem is on the left side of the equation. This tells us to move the graph 1 unit to the right. That's fine. The transformation properties tell us what to do in that situation. But over here, we're adding 1 to y over 3. The transformation properties don't tell us what to do in that situation. Okay, let's try pathway number 5. We have the parent equation. We're replacing x with negative x. That tells us to reflect across the y-axis. Then we're replacing y with y over 3. That tells us to multiply all the y values by 3. And then we're replacing x with x minus 1. That's okay. But then we're adding 1 to y over 3. The transformation properties don't tell us what to do in that situation. So far we don't have a pathway that we can use, so hopefully the last one's going to work. We'll start with the parent equation, replace x with negative x. That tells us to reflect across the y-axis. Then we're replacing y with y plus 1 and x with x minus 1. That tells us to move to the right 1 and down 1. So that works. That's fine. You see, we're subtracting 1 from x, and we're adding 1 to y. So that the transformation properties tell us what to do in that situation. And then we're writing the exact same equation, except we're dividing y by 3. That tells us to multiply all the y values by 3. So that, that pathway works. So it looks like we're going to use pathway number 6. If you said to use pathway number 6, then you're correct. So let's unveil the pathway. So we're going to reflect first, then translate, and then dilate. So we're going to start with the parent graph, of course, and it's just a V. So if you got your V, good job. Then we're going to reflect across the y-axis. Now notice that when you reflect this particular graph across the y-axis, It doesn't really change the graph. And then we're going to translate. We're going to move down 1 and to the right 1. And there you go. Whoops, that should be orange. All right, and then we're going to stretch vertically. We're going to multiply all the y values by 3 because we're dividing y by 3. Remember, it's the exact opposite of what you would think. So we're going to multiply all the y values by 3. So the y value at this point is -1, so it's going to become -3. And the x-intercepts don't change. The y value at this point is 1, so it's going to become 3. And at this point, you can just use the slope. We go up 3 and over 1, up 3 and over 1, and so on and so forth. Then we just connect the dots, and there you go. So if you got that graph, excellent. Make sure you choose the appropriate pathway, and good job if you got that one right. If you made a mistake, that's okay. Just go back and figure out what you did wrong. Go ahead and try number 6. Choose the appropriate pathway, or the best pathway, and when you come back, we'll do it together. Okay, we're back. So we have the parent equation. We're replacing y with y minus 2 and x with x minus 5, so that means go to the right 5 and up 2. So the transformation properties tell us what to do in those situations. Then we're dividing y minus 2 by 2. The transformation properties do not tell us what to do in that situation. If we were only dividing y by 2, then that would transformation properties would tell us what to do. See, if we had y over 2 minus 2, then we'd know to multiply all the y values by 2, but that's not what we're doing. We're not just dividing y by 2, we're dividing y minus 2 by 2. And then we're writing a negative. We're not just writing a negative on the y, we're writing a negative on y minus 2. So in both those situations, the transformation properties don't tell us what to do. So let's try pathway number 2. We're starting with the parent equation. Sorry, this program likes to throw us around. We're replacing y with y minus 2 and x with x minus 5. That tells us to move to the right 5 units and up 2 units. Then we're writing a negative on the y minus 2. Again, the transformation properties don't tell us what to do in that situation. Then we're dividing negative y minus 2 by 2. Again, the transformation properties don't tell us what to do in that situation. So let's try pathway number 3. So we have our parent equation, and sorry, my computer's going slow. Then we replace y with y over 2. That tells us to multiply all the y values by 2. Then we're going to replace y with negative y. That tells us to reflect across the x-axis. So the transformation properties tell us what to do in every one of those situations. Then we're going to replace x with x minus 5 and y with y minus 2. The transformation properties tell us to just move to the right 5 units and up 2 units. So that pathway works. without any kind of modification of the expression. So we could use pathway number 3. All right, let's try pathway number 4. We have the parent equation. We're replacing y with y over 2. That tells us to multiply all the y values by 2. Then we're going to replace x with x minus 5 and y with y minus 2. That works. That just tells us to move to the right 5 units and up 2 units. Because we're subtracting 2 from y, if we were subtracting 2 from negative y, or subtracting 2 from y over 3, or 5y, or something like that, then the transformation properties wouldn't tell us what to do. But we're subtracting 2 from y and y alone. And we're subtracting 5 from x and x alone. So that tells us to move the graph 5 units to the right and 2 units up. So that's okay. It's the last step that's the problem. We're writing a negative not just on the y, we're writing a negative on y minus 2. So the transformation properties don't tell us what to do in that situation. Okay, and now we're going to, we're writing the parent equation in pathway number 5. We're going to replace y with negative y. That tells us to reflect across the x-axis. Then we're replacing y with y over 2. That tells us to stretch the graph vertically. Multiply all y values by 2. And then we're replacing y with y minus 2 and x with x minus 5. So that's completely fine. That tells us to move the graph up 2 units and to the right 5 units. So pathway number 5 works. All right, pathway number 6, we have our parent equation. We're replacing y with negative y. That tells us to reflect across the x-axis. Then we're replacing y with y minus 2 and x with x minus 5. That tells us to move to the right 5 units and up 2 units. But here's the problem. We're dividing that entire expression by 2. The transformation properties don't tell us what to do in that situation. All the transformation properties tell us is that if you divide y and y only by 2, then you multiply all the y values in the graph of the previous equation by 2. But we're not just dividing y by 2, we're dividing negative y minus 2 by 2. Okay, so let's use pathway number 5. And I'm using pathway number 5 just because it's closer to us. So we're going to reflect. Whoops, I forgot to reflect that. So we should have negative y equals x squared. And then we're going to dilate, and then we're going to translate. So we're going to use pathway number 5. Let's draw our parent graph. You have all those reference points. And we're going to reflect across the x-axis. So that flips the entire graph down, like so. And then we're going to replace y with y over 2. That means we're going to multiply all the y values by 2. And so then we have the following graph. Then we're going to move the graph up 2 units and to the right 2 units. Translate. Up 2 units and to the right 5 units, that is. And let's see here. 1, 2, 4, 8, 1, 2. Looks like we have some points there. Remember, you can always resort to plugging in x values into the equation. Okay, and that is your graph. So if you got that one right, excellent. If you made a mistake, that's okay. Now, I used pathway number 5. You may have used pathway number 3, but you should get the same graph. Okay, so we have 2 more of these problems, and then we'll be done for the day. Why don't you go ahead and try number 7, and be aware that when you write a negative on the x, 2 times negative x is the same thing as negative 2x, what you see in this expression up here. So just be aware of that. So go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. So this is an exponential relation. We're going to start with the parent equation. It's base 2, obviously, because the base in the equation we're trying to graph is 2. And then we're going to replace y with y plus 1 and x with x plus 3. That tells us to move the graph 1 unit down and 3 units to the left. Then we're going to replace x with 2x. That tells us to divide all the x values by 2. And then we're going to replace x with negative x. That tells us to reflect across the y-axis. So pathway number 1 is going to be very convenient when using the transformation method. Pathway number 2, we're going to write the parent equation, replace y with y plus 1 and x with x plus 3. That tells us to move the graph 3 units to the left and 1 unit down. Then we're going to replace x with negative x. That tells us to reflect across the y-axis. Then we're going to replace x with 2x. So it looks like we have another pathway that works. Then we're going to, in pathway number 3, as usual, we're going to start with the parent equation. And we're going to replace x with 2x. That tells us to divide all the x values in the graph of the previous equation by 2. Then we're going to replace x with negative x. That tells us to reflect across the y-axis. And the last step is where we have the problem. We're adding 3 to negative 2x. The transformation properties don't tell us what to do in that situation. So we could figure out exactly how it modifies the graph, but we'd have to change the expression. Okay, in pathway number 4, we're going to start with our parent equation. And then we're going to replace x with 2x. That tells us to divide all the x values by 2. Then we're going to add 3 to 2x. That's where the problem lies. The transformation properties don't tell us what to do in that situation. In the next step, it's okay to replace x with negative x. That just tells us to reflect across the y-axis. But that one step is a problem. It complicates things. Now, pathway number 5, we're going to start with the parent equation. We're going to replace x with negative x. That tells us to reflect across the y-axis. Then we're going to replace x with 2x. That tells us to divide all the x values by 2. And then we have the problem. We're going to add 3 to negative 2x. The transformation properties don't tell us what to do if we add 3 to negative 2x. Okay, pathway number 6, we're starting with the parent equation, replacing x with negative x. That tells us to reflect across the x-axis. Then we have a problem. We're adding 3 to negative x. The transformation properties don't tell us what to do in that situation. Then we're replacing x with 2x. The transformation properties do tell us what to do, but we're already off track before we get there, so we're going to use pathway number 1. We're going to translate first, then dilate, then reflect. So let's draw our parent equation. Remember, there's a horizontal asymptote. And plug in 0, we get 1. Plug in 1, we get 2. Plug in 2, we get 4. And that's plenty of reference points, at least as much as we can fit on the window. Okay, then we're going to translate. We're going to move down 1 unit and to the left 3 units. So that's going to change the position of the horizontal asymptote. And this point here is going to move to there. If we move it down 1 and to the left 3. And then we have another point there. And if we go up 2 and up and over 1, we have another point. And we can connect the dots. Okay, so there's our other graph. Now we're going to dilate. We're going to divide all x values by 2, so that is it's not going to change the horizontal asymptote. If it were a vertical asymptote, it would change it, but it's horizontal. So dividing all x values by 2, this point moves to there, and this point moves to there, and this point moves there. Just dividing all x values by 2, and we can connect the dots, and there you go. Okay, so now we're going to reflect across the y-axis because there's a negative on the x, or next to the x. So that's not going to change the position of the horizontal asymptote. We're just going to flip all those points to the other side of the y-axis. It shouldn't be too difficult. And there we go. So we're moving through this kind of quickly because we already went over all these principles in the previous classes. Okay, so if you got that graph, good job. Okay, I want you to try number 8, and when you come back, we'll do it together. All right, we're back. So the parent, the parent equation is 1 over x because we have a variable in the denominator. So we have the right parent equation. Then we're going to change y to y minus 1 and x to x minus 1. The transformation properties tell us what to do in that situation. Move to the right 1 and up 1. Then we're going to divide y minus 1 by 3. The transformation properties don't tell us what to do in that situation. We could figure it out using the transformation properties, but they don't tell us directly what to do. Then we're writing a negative on y minus 1. Again, the transformation properties don't tell us what to do. All right, let's try pathway number 2. We have our parent equation. Then we're moving to the right 1 and up 1. The transformation properties tell us what to do in that situation. But we're writing a negative on y minus 1. The transformation properties don't tell us what to do in that situation. And we're dividing negative y minus 1 by 3. Again, the transformation properties don't tell us what to do in those situations. At least they don't tell us directly. If we change the expressions, the form of these expressions here and here, then we could use the transformation properties. But we don't want to change the form of the expressions. We want to make it as simple as possible. So let's try pathway number 3. We have our parent equation. then we're dividing y by 3. The transformation properties do tell us what to do in that situation. We just multiply all the y values of the graph of the previous equation by 3. Then we replaced y with negative y. The transformation properties tell us what to do in that situation also. We just reflect across the x-axis. Then we replace y with y minus 1 and x with x minus 1. That tells us to take the graph of the previous equation and move to the right 1 and up 1. So the transformation properties tell us what to do in that situation also. So if we want to, we can use pathway number 3. Let's see if we can find any other pathways. We have our parent equation. We're replacing y with y over 3. The transformation properties tell us to just multiply the y values by 3. Then we're going to replace y with y minus 1 and x with x minus 1. The transformation properties do tell us what to do in that situation. We just move to the right 1 and up 1. But here's where we have the problem. We're replacing y minus 1 with negative y minus 1. The transformation properties don't tell us what to do in that situation unless we modify the expression. So there's nothing wrong with that pathway other than the fact that we can't use the transformation properties the way that they're written without modifying the expressions. These expressions here. So let's try pathway number 5. We have our parent equation. We're replacing y with a negative y. That tells us to, whoops, wrong color. That tells us to reflect across the x-axis. And then we replace y with y over 3. That tells us to multiply all the x values by 3. So far everything works. And then we're going to replace y with y minus 1 and x with x minus 1. That tells us to move to the right 1 and up 1. So pathway number 5 is going to work also. We can use pathway number 3 or number 5. Let's try pathway number 6. We have our parent equation. We're replacing y with negative y. That tells us to reflect across the x-axis. Then we're going to replace y with y minus 1 and x with x minus 1. That tells us to move to the right 1 and up 1. But then we're going to divide all of this by 3. Well, the transformation properties don't tell us what to do in that situation. If we were just dividing y by 3, if we had that expression and we transformed this expression or converted the form to this expression here, then that would tell us we just multiply all the y values by 3. But we're not just dividing y by 3. As you see there in red, we're dividing negative y minus 1 by 3. The transformation properties don't tell us what to do in that situation. So I'm going to use pathway number 5. So let's unveil the pathway that we're going to use. So we're going to start with, as you can see up here in orange, well, let me use a different color. We're going to start with reflection, and then we're going to dilate, and then we're going to translate in the last step. Now notice I didn't write parentheses here. You actually don't need to write parentheses. Using this pathway, we replace y with y over 3, and the negative can just hang out in front. And if you then replace y with y minus 1, the negative can just stay in front of the fraction. Now you can take this negative and put it up in the numerator, but you'd need parentheses at that point, or you'd need to change the signs of both these terms. So don't worry about that, the fact that I didn't use parentheses. Okay, so now let's graph. So remember, in our parent graph, we have two asymptotes on the x and y axes, and then we have our 6 points, 1, 1, 2, 1 half, 1 half, 2, negative 1, negative 1, negative 2, negative 1 half, and negative 1 half, negative 2. Those are the same 6 points that we always graph with the reciprocal relation. And then we're going to reflect across the x-axis because we're replacing y with negative y. That's not going to change the position of the asymptotes. But we're going to take all the points and reflect across the x-axis. So we get the following graph. We can connect the dots. Now we're going to dilate. We're replacing y with y over 3. So we're going to multiply all the y values by 3 in the next transformation. That's not going to change the position of the horizontal asymptote because the horizontal asymptote is at 0, y equals 0. So if you multiply 0 by 3, obviously it doesn't go anywhere, so the horizontal asymptote is going to stay there. This point here has a y value of negative 1, so the new y value is going to be negative 3. So that point went there. This point has a y value of negative 2, so the new y value is going to be negative 6. It's going to be somewhere down there, 1, 2, 3, 4, 5, 6. So that goes there. So that point went to there. Then the y value of this point is negative 1/2. So multiply by 3, and that's going to give us negative 1.5. So there's the 3 points in the fourth quadrant. Now this point over here at negative 1, 1, that has a y value of 1. So it's going to have a new y value of 3. And this point here has a y value of 2, so that's going to have a new y value of 6. So that's up there. And this point has a y value of 1/2. It's going to have a new y value of 1.5. So again, multiplying all the y values by 3. So now we're going to connect the dots. So we dilated. That's a vertical stretch. Now we're going to translate, so we're going to move the entire graph 1 unit to the right and 1 unit up. So that's going to move the asymptotes. And if we pretend that this is the origin, we can just find these same points. So this point was 1, negative 3. So pretending that this is the origin, we go to the right 1 and down 3. So that point goes there. And this point here is 2, negative 1.5. So out 2 and down 1.5. We get that point there. And this point down here is 1/2, negative 6. So that point goes to there. And this point here is negative 1, 3. So we go to the left 1 and then up 3. And this point is 2, 1.5. So we go out, or excuse me, negative 2, 1.5. So we go negative 2 and then up 1.5. And this point is negative 1/2, 6. And it looks like that's going to be off the window, so we can just connect the dots there. And this is our final graph. So if you got that one right, good job. That's the final graph. Okay, so that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or study for tests, you can do that now. Here's screenshot number 1. and number 2, and number 3, and number 4, and number 5, and number 6, and number 7, and number 8, and number 9, and number 10, and number 11. But don't go before you get your homework. Let's take a look at the homework. So here is the homework. Get a picture of that. And the next page of the homework. And next page. And next page. So that is the homework. Don't go before you get the answers though. So here's the answers for the homework. You don't have to use colors, you can just use checks and crosses. And you don't have to use colors for your graphs either. So if you don't have colored pens or pencils, that's okay. It's not really necessary. Remember, this is not an art class. So just a black pen or a pencil or a digital pen is fine. Okay, so get that homework done, and I'll look forward to seeing you in the next class.